Happy Monday and happy 2023 as well. It's the first
Yeah,
episode
that's
of the
right. This
year.
is
So
I completely forgot. This is the first episode of the new year.
yeah, it is. So awesome. Good morning, Chip. How you doing?
Hey, what's up? Are,
Thank you for
are,
getting up early to join us, by the way.
are you not in the same time zone as me? Where are you in
No, we're in Salt
Utah?
Lake City. We're in
Mountain
Mountain
Okay.
Time.
time. So yeah,
Yeah.
hour
So
later
yeah,
than
okay.
Pacific.
Maybe you guys are the founders that I should aspire to like wake up early and like having podcasts before 5 a.m., you know?
No, I think I replied to your email at 5 a.m. I was already up. So,
That's cool.
yeah, I'm
Yeah.
not one of those guys who will take a picture of my watch at like 4:30 in the morning and post it to social media. That's
And then go back to sleep.
and go back to
Oh,
yeah. That's exactly what happens. Yeah, it's like so,
yeah.
so anyway. Well, welcome, Chip. For people who don't know who you are, do you want to give a quick intro?
Yeah, my name is Chip. I work on a company called Claypot AI is to provide infrastructure for real-time machine learning, and we use streaming a lot. And Joe and Matt just told me that like streaming is still a buzzword, and I was like, what? It has been around for like a decade. It's like microwave. So I don't know. Yeah.
I mean, it's still a buzzword because why is it still a buzzword? I think because a lot of companies are still struggling to implement it, to be quite frank, and so it's still treated as this magic elixir that they can't quite obtain. And then to your point, like other companies have been doing this for a long time, and it's just kind of standard.
Yeah. So
But
okay. So
yeah,
whatever technology is hard to do is a buzzword. Okay, got it.
in this case,
Yeah.
Thanks, Matt. So, awesome. But yeah, we want to talk about streaming, and I think whatever else is on your mind today. I think the name of the I guess the convo is switching from a batch to streaming mindset. What's Oh, and Scott has a quick question for you. I'm sure the other audience is. Are you on a treadmill?
Whoa, yes. I think I find this like a very good conversion starter. And I feel like I should start charging for like I know to get affiliating link with a treadmill company. But yes, I'm on a that on a desk treadmill.
Okay, so you can get that with the discount code Chip. Um,
Keep
20% off of your
streaming
treadmill.
forever. Like
That's awesome. Yeah, but what's up with the batch to streaming mindset? What's in your mind with that?
um how to say that? So wow, we just some shred Ryan. Okay, that's
Let's
great.
just jump
Man,
right
I,
in. Sure.
I think like I
Don't have a
still
lot of time.
haven't drank my coffee yet.
Okay.
Okay, so I think well I think we can really slowly like unpack a lot of it.
Yeah.
But I do think that so like I said, a lot of people still think streaming is a buzzword, and I think there's a misperception that like okay we have to like, abandon bash and go to streaming, and I think maybe that's where the problem is because it's not an or, it's just like whatever use case, if you're okay with data being a bit stale, then yes, do bash. But you want data to be more fresh because it can improve significantly, so more performance, it can bring more business value, then maybe we can do streaming. So for us, we think of ourselves as more technology agnostic company. So technology changes over time, right? We have seen many things come and go. So the question is like here we have an use case and we have this requirement. What technology is the best for us to leverage to meet this requirement? And it just happened we see a lot of companies because they are terrified of certain technology. You just don't touch it. And I don't think it's the right way to go about it either.
Interesting. You use the word terrified. What? Why do you think that is?
So I think it's like I'm slowly understanding. Like I'm slowly trying to understand more like why people are terrified of streaming still. Like a lot of people are not. Because it's just strange because I could meet like fresh out of college engineer and they don't have that like scare like oh hey like I'm starting on streaming. They just run right in, they learn like fling sequence, understanding, they understand the like time semantics concept, and they just get just right. But at the same time we meet some engineers with a lot more experience, and then they were like oh no streaming is hard. So I think it's slowly like I think like it's more of a mindset of like a mental block, like okay if we do streaming then it's hard. So first time I talked to this team, and they just explained to me this that it started just blow my mind. So it was just like there's a difference between an on-off job and a long-running job, right? So when you compute something like, say, the average, like quick setting, the average value, like if you have like a CSV file or data in a table somewhere, you run it once, you get the average value, and you're done, right? But then if you do it with on streaming data, then because it's incoming, So you don't compute the data once, the value once, and you're done. So the value is gonna keep on like refresh, like when the new value coming in. So now it's not one off task anymore. It's a long running job. And people was like, oh shoot, now I have to maintain a service because I think of and it was like, okay, that is too much work. It's like scary. So in the batch world, that if you want to like schedule recompute, like if you want to recompute the same task like every day or every hour, you rely on something like scheduler, like an airflow, like and something. And then people like so the people write the logic to do the task, and the people who do the scheduling are different. It's like, okay, now somebody manage the airflow for me. But in streaming, you don't really have that concept of like scheduling. It's just like they're always coming in. So by default, it's keep on refreshing. And that was like really cool.
So is that where the struggle is? Because I do feel like technologies like Kafka, or especially things like Kinesis, are really table stakes. Like you can just go into AWS and turn on Kinesis, but maybe it's the computing that's really throwing people off the real-time computation of statistics.
So I would say just like I do think the computer like it's just streaming like what is this it's just log. Like you really just like you write like a pen only, you have like one event and then another. And it's just like that. So I think what you say is right. Like that's the aspect of computations and also storage. Because now if you want to deal with fresh data, like the whole point of like computing value fresh is so that you can use that value very fresh. So now you have to store a lot of things in memory for low latency access. And that could be like cause a little bit of the trouble as well. And I depend on the use case. We see a lot of companies are like okay with like second level latency, but if you want to go into like milliseconds and especially at scale, it's a lot more challenging.
Interesting.
So I know how about you on the show? Have you like talked to a lot of companies interested in streaming? Like what have you heard
Yeah,
people
we've
saying about
had quite a
streaming?
few
Yeah.
quite a few guests about streaming, and I'd say we've also spoken, on podcasts about streaming and conferences, I guess, with some streaming companies too. So, yeah, I would say it's interesting. I feel like it's one of these topics that, as you point out, has been around forever, and it feels like now. I think what Matt and I are sort of expecting is we're sort of in this interesting renaissance phase where I kind of like how the modern data stack sort of democratized data warehousing, in the cloud to the masses. I feel like we're at the cusp of something with streaming in real time and that being made more available and easier to use, across a variety of use cases. I feel like this is sort of the next phase of where the tech stack is really going is real time and so I
Yeah,
think
I do
it's
I do
cool.
see. Yeah, I feel like people like see the problems. It's just I think it's just
Yeah.
like not yet a good solution because I have never in my life like talked to a company and say like yes our data is too fresh, we need to slow it down a little. It's never or
Right.
or like people was just like nobody enjoy managing two pipelines. They was always like hey here we have a batch pipeline, now here we have a streaming pipeline. There's some companies they have like streaming team and there's somebody have like batch team when in theory it's the same data, like you have some events coming in at first in the Kinesis or Kafka, and after like a little bit delay, it's made available in data warehouse. So
Yeah.
like it's the same data. There's no like we talked to a company who successfully like unify the streaming batch or like just move a lot of a bunch of work to streaming because the more computation they can do like upstream, then the less computation you have to do later on. So it was just like push more computations like predicate push down. So you just like do more computation upstream, and this just says like oh this makes their life like so much easier because now they only have to maintain like one pipeline and their code base is so much smaller, and I know the computation time is so much faster. I know I feel like I'm trying to sell I don't know. I don't know. What am I trying to sell? Like
You get
insurance
the
or something?
discount code stream 20% off. So you get a free treadmill thrown into that.
I'm not associated with Confluent or anyone. Just FYI.
No. For full disclosure, we're partners with companies like Confluent and Red Panda sponsored our book, and so but we really don't have a
Yeah.
dog in the fight at the end
Yeah.
of the day. And I think Matt and I both agree with your take too, where if you could get your data, as fresh as possible, why wouldn't you? I mean, it's I like baked bread fresh out of the oven. I don't really like to wait 5 days
Yeah.
for it to so it's data is the same way. And at Flink, I know their philosophy is well, batch is just it's a special case of streaming, and
Yeah.
I subscribe to that. So.
And that's essentially the philosophy of like Apache Beam as well, which I don't think is as popular as Flink, but Google has
Yeah.
really pushed that pretty hard as well, this core concept. And I think it's very big internally at Google too.
Bounded and unbounded
Yeah,
context.
exactly.
Yeah.
Yep.
Yeah. That is, yes. So I think that's concept like bounded, unbounded, and I do think there's another. So it's not especially related to streaming, but one thing in like in data engineering in general that I thought very very interesting is the decoupling of API from computation engine. So what does that mean is like, so people like to make things happen when the data is right. And I was like, okay, I don't want to bring my data to the tool. I want the tool to come to my data. So like first of all, your data in Snowflake, then you want to query in Snowflake SQL. Then you data in like, I don't know, some Spark, into Spark SQL or whatsoever, and or like in so I think that's interesting, but actually like we feel like everywhere we have different flavor of SQL or different types of like APIs, and like if you change your where the data is, then you're gonna have to rewrite the code a little. So I think like if we just accept for the fact that data can be anywhere, it can be in multiple places as one, then suddenly when we see the need for different abstractions. So on APIs, it can operate on different with data at different locations. So like now we need the need. So I think we see some company now start having this compiler layer, so they can have like one API, and then it compile into different underlying computation engines depending on the data is. And that's just very interesting. I see a lot of people like it. Like everyone I hear, we want this universal compiler, and then there's always like, but it's never universal enough. And now you have like one that extra thing that has to maintain. But I do think this is a very interesting direction that I've seen.
Mm-hmm. You look like you're pondering something.
No, I'm just thinking about this question more generally, and I think that's better abstractions of streaming, I suppose, are the future. That's part of what is going to make this whole process a lot easier.
What would that look like to you?
I don't know. That's a good question. I've got to think more about that. But yeah, certainly, like, again, going back to Apache Beam, there's this idea that you can push down to multiple computation engines and you don't have to be quite as close to the metal anymore.
Yeah.
So as you scale, for example, you can switch engines, you can process locally, then your code will just scale up seamlessly as you go up to larger sizes.
But should you even be thinking about that?
I don't know.
Yeah. Yeah.
So have I been like saying something too interesting? It's just like not the last one word.
Oh, don't worry about it. But yeah, I mean, so the work you're doing at Claypot, tell us about that. I think that's actually relevant and also super interesting.
Well, so what we're selling is this like magical tools that regardless of what the data is, you're gonna get some magical latency with like super low cost. I'm just kidding. That's what like I feel like that's what every tooling company is that you go to the website, it's like reduce from days to seconds, like guaranteed, like SLA, and like the minimal cost is just, I don't know, it's feel like it's so hard to differentiate ourselves nowadays because everyone is so magical. So what we do is like we try to tell our customers that we are not really magical. Like if you want really late, like really good latency, then something has to give. So we want to like expose the trade-off better for customers. So first of all, like latency, right? If you want really low latency, then maybe it's gonna cost more, or it's gonna be less accurate, like less correctness, because now you have to compute things fast, and in when things happens in productions, some things might arrive late, right? So like if you wait for your late arrival event to compute, then it's gonna be stale. But then if you do it before the event arrives, then you're gonna be less correct, right? So I think that it has something has to give. So I do think that we want to like make it easy for people to understand the trade-off, and they can do so without like with just like configuration, instead of like trying to rewrite their code or changing their jobs.
Interesting.
Yeah.
Yeah, I mean, does this have to do? I mean, in your book, Designing Machine Learning Systems, I think it's called. You in chapter 9, you go through this whole notion of continual learning, which I thought was like really fascinating. I think anyone who's done ML, this is it seems like this is what you should do. Just straight up batch, but it's also like there's a lot of fill in the blanks parts along the way. So it was walk us through that. You had some interesting things in there. I want to touch on that. It was kind of the notion of what was it, stateful processing and then testing in production are two of the things that stood up to me as fascinating. And also, especially the last part, testing in production, I think people would probably look at that and potentially
So
get
it's
terrified. But
interesting that you brought up the term stateful. I
yeah,
do feel like as an engineer, like whenever I hear the term like here you have to manage state, it's I know it's like I'm gonna like have to like work like extra hard, right? Because like it's a lot easier with the right things. Don't care about what has happened before, like self-contained. Like I know functional programming is very big on it because everything is like it's a lot easier when you don't have state. But in like there's a whole thing of stream computation or like the whole not streaming, it's just like just even like bash if you want to know like keep track of states, and it adds another layer of complexity to the code. So say like so let's say on a simple case you do machine learning and you want to train a model on a certain amount of data, like maybe it was the last 6 months or it was the last 9 months. Like processing data, like you go back, like some companies they have like a lot of like data points every day. So processing was the last 6 months can be quite expensive and slow. So like if you do it over the last 6 months, and if again you want to change over like maybe from like May to sorry, I don't know how to calculate 6 months, May to like October, and then again you want to go from June to November, right? There's a lot of overlapping. Like if you can find a way to keep track of those states. So if you change the training data partitions, you don't have to recompute from scratch, right? You just need to like recompute a new one. So it's a part of continual learning. So right, like instead of like training the models just on like owns the data all at once, you just refresh it on the new part of data. So we see that a lot as well, like in batch, impact batch predictions. So let's say you have an app, and you have like 10 million accounts, right? And if you do batch prediction, you have to like just generate recommendations for all of these 10 million users. It takes a lot of time. And so like a company told me that I have to compute prediction for the 10 million users, it takes them like 6 hours. So they can only compute like at once every 6 hours, and that is their limit. But the problem is that like not all of these 10 users log into their account that day. So like the vast majority we see is only like 2%, or like if a company is really addictive they have like 5%, then like more than 90% of the computation is like it's just wasted. So if there's a way you can like know like what has changed, and you need to recompute what had changed, then that could like I feel like so that's why we say as a company, okay, maybe that is a first step you should figure out, because it's just like there's so much wasted computations like everywhere we see.
And so, what, in some sense, what we're talking about is hybrid batch and streaming, which that is one of the notorious problems in modern technology. Like doing pure streaming all the time, to your point, is very, very inefficient. Having to redo all your computations every time you get a new event, for example, is completely
No, I
untenable.
think I think streaming does like a lot of it's stateful, right? The whole streaming computation that you have, like you
Mhm.
manage state. So like say you have so they have like an interstate, a checkpoint, a set point, right? So
Mhm.
like you say if they count, like you count the number of views a product has. So it's only refreshed like whenever you have a new event, a view event on that product. It doesn't like say that if say I want to see like, how many views this product has over the last hour. It doesn't look back the entire hour and just like a compute again. It's just like refresh a scout with a new event. Does that make sense?
Yeah, yeah, definitely.
Yeah.
cool. Actually, got a lot of questions here. I
Yeah,
don't know if
yeah,
you want
we
to take
have.
some audience questions
Yeah.
here, but people are asking. So we'll start with do do I hope I'm pronouncing his name right. I don't know. So at the beginning of the project,
I just
what's that?
I just feel like sometimes you might just want to ignore a question because you don't know how to say the name of the person who asked a question. I know say his name. It's Vietnamese. Zui again. I think
Okay,
so. Yeah.
awesome. Yeah, so I guess we just take I don't know, we could have a whole show just people with hard to pronounce names and just yeah, it'd be a fun show on its own. But yeah, it's a good question. At the beginning of a project, there's not a lot of data, so is small amount of data suitable for streaming?
Um. So I think like I don't think the question is just like should I use stream or not. I think it is more of a decision tree. Like you start with requirements, right? You say like, hey, what is your latency requirements? And second is that maybe like what is a business logic look like, because there's certain business logics that doesn't make sense to do in stream. So like streaming is very good for like we say like where, because stream computation engines right have the state, so it's very good if you have some kind of like logic that aggregate over time. So say that if you keep on counting number of views, or if you keep on computing the mean transaction value, or things like that, right? Because like you check the state, but you do some things like, is this transaction value greater than $1,000 or not? So that you can just compute that. You don't need to keep state. It's just like, so it doesn't really need streaming. Like you can compute that using like a, I don't know, like real time, like you can just, you just do it using like a simple logic. Now you don't need a stream or engine to back it up.
Mm.
So it really depends on the requirement. And yeah, so like there's not a lot of data. It's not a bad thing. It actually makes things a lot easier, because like I feel like everything is a lot easier when you don't have a lot of data.
One really nice thing now is that with cloud services, you can basically scale to zero in a lot of these services. And so if you're starting with just a few events, but you know that eventually you're going to have a lot, you can just turn on, say, Kinesis, serverless, and then scale up from there. It's not a perfect solution, but it's not as expensive as it used to be. You don't have to stand up your own Kafka right off necessarily.
What are your thoughts though on synthetic data when you're getting started out? If you don't have a lot of data and you want to mock things out, is that a way to go?
Yeah, I feel like that's great. I think like so when we, I mean, anyone's like should care about data schemas, right? So like given, so once you have like, what data expect should like look like, and you can just, there's a lot of like I think we're just looking it up actually. There are a lot of packages that help you like generate data. You have a schema, it can help you generate pretty nice. And even like ChatGPT, I was playing with it. I was asked ChatGPT to help me generate some fake data for training, and it did pretty well. It was just like so it was like started telling me, okay, like if you want the data to be more realistic, then you need to import this like figure. And was like, okay, what is this like package figure looks like, and it helps me like show it. So I think like generative AI is getting to the point when I do think that it might be very possible to just use it to generate like fake data according to some schema. But if not, you can just like write some script. Because if you know what the data is supposed to look like, then you can just like randomize it.
That's interesting. Let's see, going through the questions here. Carlos has a question. Yes, might the issue with streaming adoption be that organizations struggle with data governance and data quality, even with batching, let alone streaming?
So I do think it's like there are two different aspects, right? First of all, I mean, I'm curious, Matt and Joe, how could you respond to this question? You must have seen. Okay, you work with like company, you're like consultants, so I feel like would always have very fast, intelligent response to give.
Oh, thank you very
fast.
much.
I don't know about intelligent, but we sound like we know what we're talking about.
No, let's Matt. Intelligent sounding answer will sound like a chat GPT answer. And it'll be completely wrong. No, I would say, okay, so I may invert the question, Matt, and ask you, how many times have you seen data that seems like everything's well governed and it's of the highest data quality?
I mean, it's rare, right? But there are certainly companies doing it. You don't see it every day, though, and especially the stagnation problem that can occur with companies that have already invested a lot in data, where they've bought tools but they haven't invested enough in data quality. And you do have like a sort of bootstrapping problem as well when companies are trying to get off the ground, and sometimes they get very fixated on technology but not governance and these other issues that actually are really critical, which you also emphasize in your book, right? If the data isn't good, then good luck. Like your machine learning, it's not. Yeah.
I can give it a shot. So I think like for data, first I think it's like first is it data quality. Like let's talk about it. So so how to ensure data quality? I do think this, like say like I think of this as like an example of like when was the last time you went to a party?
Last time what?
You went to a party.
I went to a party. Probably New Year's.
I don't know. So you seem to be like somebody who could like go to parties a lot.
I'm a party guy, so.
So thing is, like example, like so imagine data quality is just like you have some like guardrail, maybe like a browser, to make sure that everyone pass through the door is like conform to the code, right? So if you do in the streaming, like say in batch, like you get everyone into the room first, and it's like, okay, who doesn't like dress up to code or something. That could be like quite hard, right? But like streaming, like you have a guardrail, and then every event a person's going through the door and say, okay, is that person not out, right? So I do when I do things at data quality in streaming, it seems like a lot more natural because you do it
Yeah.
from like upstream, like a data coming in. You can like when you specify a schema for the data, you can specify the expectations to see like, okay, that event, like the transaction amount has to be non-negative, this location has to meet, like has to exist, right? And you just check it with every event coming in. So and the question of like data governance, I don't think it's just a batch of streaming. It's just with data in general, and governance is pretty has different, a lot of different aspect to it. But one thing that I thought is very interesting that we've seen a few big companies very interested in recently. Not recently. I mean, I don't think it's by choice. It's just like basic requirement. It's just like column level. So I do so column level privacy settings, right? So say if this column A is supposed to be sensitive, like PII, then like if anyone access it, it has to be first be masked. Second, like not everyone can access it. It has to be in some sort of access control group. And third, which I think is very big, so I don't think like there's not any good tool for it yet, is privacy control inheritance. So say like if the data derives from column A and column A is marked to be sensitive, then all the data that derive from that should also be marked as like have the same like sensitive setting, privacy setting.
Awesome.
So I don't think it's a matter of like batch streaming. It's a matter of like how do you construct your computation flow so you can like make sure that all of that is like.
Yeah, I completely agree with
yeah.
that. Yep. Yeah, exactly.
And I mean, it's tools to do these things, right? Like permission management tools are really critical, and also just practices within an organization. There's this whole organizational aspect of making sure
That's so huge, though, isn't it?
It's if you have the tools but not the organizational part, you'll never get there.
Yeah.
I mean, have we ever seen a counter example of that? No, I didn't think so. So I'd be like, Matt, where you been at? Let me see what other questions here. Again, there's been so many questions here. I just want to get through some of these here.
By the way, like behind you, is that like I don't know, is that a music studio?
Yeah, it's my man cave. So I collect synthesizers and drum machines. So
collect, as in like you look at it and
I just stare at it. Yeah, I don't actually
Oh,
play
yeah.
them. I just I play a lot of music. I also still DJ, surprisingly enough.
See, I was right.
Party,
So
yeah,
you're
yeah,
my
exactly.
party person. Wow.
Yeah, so when you mentioned clubs, I was like, yeah, I used to DJ at clubs for a long time, actually. So, and I still do on a rare occasion, not as much as I used to, but yeah.
So do you write your own like intro and outro music, something like that?
Yeah, I write. I do make my own music too. Yeah, so a lot of electronic music. I should put them up on SoundCloud. Everyone's been asking for stuff, and then again, my hard drive's full of like just tracks that I've made, but I don't know.
Mm-hmm.
It's just something I do. And I buy hardware actually because I don't like to stare at screens after a certain point during the day. So that's why I have just.
So you don't want to be using an iPad basically to do this stuff.
No. It's just
Oh, you don't want to be like so my friends have been very annoyed with me because recently I got into this of like very theme music. So I could say found an album that's like pandemic theme music. It was just like a song like Clorox wipe or something like that. Like, hey, I would like to use a Clorox wipe, and I thought it was really funny. And my friends like this is like really really bad because it's a horrible pun. I'm just hoping someone would make like a data engineering team album. So
this is your opportunity.
Thanks. I'll get right on that. Just really told me on that idea. Do you do any music?
I'm very bad. So my friends just said that I have like negative musical talent. So
oh wow.
Yeah.
Okay. So like the world cries when you play music.
Oh no, they just shut out. It's just like I think I'm
boy.
attempting to sing in like 2022, and you know what happened. So yeah. No, I'm just like I think it's very funny because my dad is a musician.
What?
So I don't know what happened. Maybe there's something latent and maybe
like skips the gene, like skips generations, and so it's it's like height or something. Yeah.
Yeah.
Like my dad's like 6'4", and like I'm like not that tall. So it just happens.
Mm.
But music's probably the same way, where it's just like, you just but you're talented at other things, obviously. Like you can write books
Right.
and give
Wow.
talks, walk on a treadmill. It's pretty cool. So
But you know what? Like when if you ask, like when I was younger, I never thought like it was like, okay, what you want to be when you grow up? Like musician is a reasonable answer, but I don't think blogger was a good answer back then. So
yeah. Yeah, it's interesting. Well, poor Andy here. He's like, I feel like we might be digressing away from the original subject. Yeah, we
sorry,
totally,
Andy.
we totally are. Sorry, Andy. Actually, next month at Data Nova, Andy and I are going to be doing a debate live on stage about data engineering and data mesh. I am picking a side in an Oxford debate. Stay tuned for which side I pick. You
Yeah.
might be surprised. Yeah. Okay. Cool. Well, back on topic here. Thanks, Andy. Nice buzzkill.
No.
So-
I know it's good. You good. Have good audience. Okay, we can go back to the topic. Let's say.
yeah,
So
it's
what?
good. Ben's got a good question here. He asks, can you talk more about the cost benefit of deciding to build streaming pipelines versus batch? He says it used to cost a lot more to manage streaming use cases, but with new technologies, how do costs compare? And then how do you make the decisions about the benefits for the business versus the cost to implement streaming processes? A long question. Just
Mm.
maybe take the first one there. But
Well, I feel like I feel like if, as a consultant, right, I probably would never say like yes, this thing costs more than the other without knowing more detail. But I'm gonna do it. I'm gonna risk
okay,
it.
let's go. Let's do it.
So I think one aspect is like understanding where the costs come from. So so like the example we talked about before, right? Like batch computation, you have a lot of opportunity for wasted computations. Like you compute predictions for like 98% of users would not even like use that prediction at all. But whereas if you have a way to like do it, like you only generate computations predictions for the users who's just logged in, then things will become like you can save a lot more computations. And another opportunity for like for cost to arise from like one opportunity for cost to arise from streaming compared to patch is state management, right?
Mm,
Because like that you have to keep like state so that you can say like so a counter and you keep the number like the counter, or is if it's average you need to keep like both sum and count, and that state can be costly. So there are certain operators that can be quite cheap to compute, like sum or average. Like you kind know like the predeterministic number of state that you need to keep. But for things like say last and sorry something like let's say like count distinct, like the number of distinct merchants users have like bought from, right? like like the count distinct, it really depend on the cardinality of the item, and it could be like one, it could be 10, it could be 1,000. So it can be like pretty hard. So I think I usually like very encourage companies to understand like how like the complexity of the logic they need to support, and
mm,
how that would translate to cost. So we actually like do like a categorizations of like transformations according to like cost and also complexity to like implement. So something like say last n event doesn't have to be costly, but it can be like pretty hard to implement. So say because like say like a lot of people use like, okay, so when was the last 10 times that users purchase an event, an item? But like the last n event could have happened like only in the last day, or it could happen like 2 years ago. And that is like quite hard to like handle. And also especially if all the events are already ordered, then I can put that in database, but like all the events are not ordered because some things might arrive late. So we actually talked to a company, so that there's something that seems very simple could be quite hard for them to do, is because so like in stream processing you have some concept like processing like at least once or exactly once, right? So like they do like at least once, so that means that they might count an event multiple times, and they found out that like the count of like some things they do online versus the count like when they later on doing batch could like be very different. Like so they don't have like very much like correctness there. So that's the certain thing that can add like extra cost, because like you need to hire people with a specific expertise, and anyone who claims to have specific expertise will be like which is good for them, but like it could be very firstly very hard to find, and also like very costly. And another is that people are afraid of is a cost of like on call. because like when you have something that's long running or is like happening, you like if something bad happened, you have a very short window to fix it before you lose data or like affect users. And I see that a lot of teams like don't want to deal with on call. So I do think that in terms of streaming, there's like a lot of people prefer to have like fully managed service, so just don't have to deal with like operational overhead.
And so it sounds like part of the problem here in transitioning from batch to streaming is just like the development and proliferation of expertise in these details, right? Because people have been working on batch systems since, well before the 80s, actually.
Since the 1800s, I think.
Yeah, really, arguably. Yeah. Like punch cards and such. Yeah.
I think that it's just like, it's just a little bit of like, if we have a little bit more, how to say, like good material to understand a certain streaming concept, things would be a lot easier. I remember when I first started on streaming, I found it's very, very confusing. So the concept of like time variant result or like time travel, point in time correctness, or like something as simple. Now I feel like a simple like watermark or like allowed lateness, right? Something you don't really have in Bash, but like it's something that's take like you 5 minutes to learn, and everything is becoming so much easier.
I feel like the education gap is still a really big thing, right? I see this across the board, actually, just in every aspect of our work. Actually, it's just most of the time it's not really the technology that's the problem. It's the education of the people trying to think through these problems and implement them. So,
well, go ahead.
It's just saying that we need an Andrew Ng of live streaming. So.
And I think in general, my comment would be we're actually very good at developing technical resources on technologies, programming languages, frameworks. Like this is a tutorial on how to do X, but it's kind of what tends to be missing in the tech education space is more conceptual. And that's why I really loved your book, because it actually spends almost no time on like specifically, this is how you use Spark to do X. It's very conceptual. And the funny thing is a lot of people who have like master's degrees in data science and such struggle with some of these core concepts that you really call out in the book in terms of designing systems, but also to how to think about machine learning problems where, say, you have imbalanced data or you don't have adequate data, and these kinds of minutiae that are actually almost more critical than the technology sometimes.
Well, it's the stuff you find out when you get onto your job.
Yeah,
like,
exactly. So you have to learn it by experience, and these resources just don't exist. And maybe it's the same case with streaming.
So I think we mentioned that it was like how to do Spark to do X. So do you know Richard Feynman? He got a very, I think he has a very interesting story about like so he very interested in biology, right? So he won a Nobel Prize for physics, but he also really enjoyed studied random subject. In one year he decided to do like biology. I was taking like biology class with a PhD student, and like so he was looking about like how like the nerves respond to different stimulations, and then he saw us like, okay, now it all has a muscle name in different part of the cat that he just didn't know. So he went and see like, and he found the map, and he just like looked at the map, and then when he was presenting to the class and he was trying to explain like where the muscle, each muscle is, and the student was like, we all know all that stuff already. And then he was like, what? It's just like, that's how you spend all your time, like just memorizing all of this when you could have just look up in like 10 minutes or 15 minutes. And I feel the same things about like nowadays. I feel like a lot of tutorial, like getting books, like people just like spend so much time just like learning like XYZ when you can literally just like look up. So I feel like it's there's of course, I mean, I appreciate it's like people who write things for to look up, but I don't find it to be very long lasting. So I did that before, like in college I did this TensorFlow course, and it has a very painful experience when I TensorFlow go moving from like TensorFlow 1.0 to like TensorFlow 2.0, and I realized like if I wanted to redo the course, I would have to update like 80% of my course materials. So it's like, okay, like everything that's like tool specific is gonna go outdated like really quickly. And if I were to learn, I would like to understand the concept. I would like to understand and spend a lot of my time understand concept, and also like hands-on trying things out instead of like trying to memorize like different tools.
I think we feel the same way. We wrote a book in much the same fashion you did, where it's like if you try and figure out what's not going to change over the next few years, right? I mean, everything has sort of an expiration date at some point, but a lot of practices, I would say, like what you described in your book, for the most part, I would say like that's the body of knowledge for machine learning. That's how it's been, and the stuff you describe kind of going forward with continual learning and stuff. I mean, that sets a good context. I don't see a lot of it that's like, oh, that's old fashioned now. It's like it could happen, but it's going to take a lot longer than if you like wrote a TensorFlow whatever X, Y, and Z version to the next. It's like, yeah, that's one reason with us we decided, okay, no technologies whatsoever in the book unless it's as a contemporary example, which you could update later. It was crazy. Like when we wrote our book, it was like the I think I counted 50% of the technologies or companies we referenced had either gone out of business or had
Oh
been acquired by the
no.
time it went to print. And we're just like, this is nuts. So
Yeah.
Yeah,
That
the
that
pace changes. Yeah.
the book is like doing very well. I think it's a really good book. I'm waiting for my signed copy.
okay.
Okay, we'll get you one.
Yeah, we'll mail you one. So,
Yeah, that
it's awesome. I know you got to cut out in a couple of minutes, Chip. So, we'll cut it a bit short. But yeah, big fan of everything you've been doing. Again been following what you've been doing for a long time. So it's cool to have a chat. Or any last minute questions you know, ask for comments?
I think
Heaping praise on her.
Yeah, no. I'll leave you a review. I love your book. It's fantastic. Really,
no,
one of the
I
best
appreciate.
machine learning
I think
books
that maybe
I've
like
read.
just one last point. I do think it's like I think that you guys work a lot in data engineering, right? And I feel like work a lot of data science, and I do think it's like you're so it's very big
Yeah, we're gonna
convergence
talk about that
from
actually.
data
Yeah,
engineering. Yeah, I'm wondering like from the perspective, what have you seen?
data engineering and data science.
Yeah,
Well, I mean, we're both data scientists that became data engineers, and so I think we have a very weird perspective on this, where we sort of know what the outcome should look like, and then we had to, I think, out of necessity, become data engineers just to do our jobs that we were hired for. Again, this was back in a time when data engineering was still, I would say, very new and very, yet to be discovered or defined. But I think there's a high intersection between these things.
yeah,
I think a good data engineer should know data engineering, but I also feel like a good data scientist should at least understand what a data engineer does. I don't know
yeah.
what's your take, Chip?
I think it's I do think that's we see a huge convergence of so like suddenly maybe it's just like first like from purely personal perspective, just people coming to me and asking it. So a few years ago asked me, hey, recommend me some data scientist, but now it's coming here, how do I find good data engineers? So
Mm,
maybe it could be got me because I'm stepping more into the streaming wall and it's more still data engineering. So it's really exactly hard to say, but we see just like more and more tools like providing like the hybrid of like SQL plus Python, because I think in data engineering you do a lot of SQL, and in data science people like still doing a lot of Python. So even like DBT, right, provide like recently introduced a Python mode, even though it's usually like SQL, and we see a lot of like future engineering tools like provide both like Python plus
mm.
SQL.
Yeah, for sure. It seems like there's an intersection of the two, and it's just you want to figure out the common languages, and I feel like there's a lot of overlap. I'll be curious to see kind of the intersection of like data engineering, data science, and machine learning engineering over the next few years. I feel like that's an area that's kind of I feel like the boundaries are in some ways artificial,
Yeah.
and so it's but where it goes, I don't know. So yeah,
Yeah.
should be fun. Well, cool, Chip. For people who want to learn more about you and Claypot, how can they do that?
Well, follow me everywhere. Twitter, LinkedIn. Yes. I need to like eventually check up my numbers. But yeah. I'm thinking like I feel like I'm very active on Discord. Yeah. Go. Come join our Discord. Say hi. I'm like too active. I think my team was like, should I be worried that you're getting too distracted by Discord? But yeah. Um.
I mean, you finished the book, right?
Well, yes. Not by choice. I mean, it's just like editors like, yes, you have to do it. You have to do it. So
At some point, you have to
You
do
have
that
to
to
get it
yourself.
done.
Yeah.
Yeah. Yeah, that's cool. Then your Discord community is huge. From what I saw, it was it's like a town.
I think I think it's a good community.
Yeah,
But I'm very
really
happy
doesn't matter.
with the community. I think they're really great people there. I think I've become like a lot of become friends with a lot of people there, which makes things like nice. I think that's what I missed after college, right? Like this like a community, and I think it's pretty wholesome. We don't take any sponsor. We do have companies. It's like, hey, we want you to like, have you organize events. And it was like, wait, are you on Discord? And they were like, no. It's like, then how? Like,
Right.
how are you gonna have us organize event? You're not participating in the discussion. But yeah,
That's awesome. Well, cool. All right. Well, we'll talk to you soon, and yeah, we'll talk offline. We'll get you a signed copy of the book.
yeah,
And
cool.
stuff here.
See ya.
Oh, awesome. All right,
Yeah,
Chip.
Take
Thank
nice
care.
you.
nice seeing you both. See ya.
Yeah.
Bye bye.
Thanks to the audience. Bye bye.